Let's solve problem 7.8 for Microelectronic Circuits 8th edition by Sedra and Smith. Design the MOS amplifier of this figure to obtain maximum gain while allowing for an output voltage swing of at least plus minus 0.2 volts, and let VDD equal 2 volts, and use an overdrive voltage of approximately 0.2 volts. Part A asks to specify VDS at the bias point. So first we need to identify what point we're actually going to be working with. So between A and B on this curve, this is the voltage transfer curve. This is the saturation region, which is where we want the MOS amplifier to be operating. And because we want to obtain maximum gain, that means we want to be at this point Q, because we're going to achieve maximum gain while allowing for an output voltage swing. It's going to allow this kind of curve to make sure that we do not exit the saturation region. So in other words, for part A, we're solving for VDS at point Q. So let's get started with that. So VDS-Q is equal to VDS at point B plus V overdrive. So what's VDS at point B? So we have this equation. We have the square root 2 times Kn times Rd times VDD plus 1, all under that square root, minus 1 divided by Kn times Rd. Now this is great, except I don't know my values of Kn or Rd. So what else can I do? Well, I can also express VDS at point B as the following equations: V overdrive plus the swing voltage from gate to source, which is this part right here. And the swing voltage from gate to source is equal to the peak value, which we see here. We want maximum output voltage swing, so it's VDS divided by the gain, AV. So we want a maximum output voltage swing of at least 0.2 volts. It's going to be 0.2 divided by, the way to express AV is Kn Rd V overdrive. V overdrive is approximately 0.2 volts, so that's going to cancel with the 0.2. So VGS is equal to 0.2. Or sorry, not 0.2. 1 divided by KNRD. The 0.2 canceled out, right? Okay, so I have this expression for VGS, which relies on Kn times Rd. So this means I can make two expressions for VDS at point B, and I can solve for Kn times Rd. So basically on the left side of the equation, we're going to have the square root of 2 times Kn times Rd times VDD plus 1, all in that square root, minus 1 divided by Kn times Rd equal to V overdrive plus our expression for VGS. What did I write Rd? It's 1 divided by KNRD. Sorry about that. Okay, so now I have two equations, and I have technically two variables, but we can treat Kn times Rd as just one variable and solve for the value of those two multiplied. So I'm going to multiply both sides of the equation by this common denominator, Kn times Rd. So that's going to get rid of the denominator in the left side. So we're just left with the square root and then minus 1. And then on the right side, we're going to have 0.2 multiplied by KNRD plus 1. Let's add the 1 to the other side. So we have plus 2 on the right side. So I'm going to just erase that for room. Okay, so we added 1. So now we have plus 2, right? Okay, now we're going to square both sides to get rid of the square root. So on the left side, we have 2 kn rd vdd plus 1 equals, so we have, if this is a and this is b, we would have a squared. So that is 0.2 squared is 0.04 times, again, I'm treating k and rd kind of as just one variable for now. Okay, plus 2 times a times b, so that would be 2 times 2 is 4, multiplied by 0.2 would be 0.8 kn rd plus b squared, 4. We can subtract 1 from the left side of the equation to the right side of the equation. So we can make that just plus 3 now. And let's subtract this 2 variable to the other side. So we have just one side of stuff, and then the left side will be 0, and then we can use a quadratic formula. So we get 0.04 times kn rd. Also VDD we know is 2, right? So we can actually change this to just 4 times all of that, because VDD is equal to 2. So we just get 2 times 2. We get 4. So let me simplify that. Okay, so 4. Okay. So we have 0.8 minus 4. That's minus 3.2. Forgot to square that. Kn rd plus 3. Now we can use the quadratic formula. It's going to be, so if this is A, B, and C, it's negative B, 3.2. For any kind of MOSFET BJT problem, when you're taking a square root, always do the plus sign. Never do the minus sign. It just always works out that way. Okay, so plus the square root of B squared, 3.2 squared, minus 4 times A times C, all over 2 times 0.04. So I calculate that this is equal to 79.05. So this is the value of Kn times Rd. Let me clean this space up, and then we can go back and solve for VDS at point Q. And we're back. Let's finish this first part A. So we calculated that Kn times Rd is equal to 79.05. And we know that VDS at Q is equal to VDS at B plus V overdrive. So now we just need to solve for VDS at B, which is equal to, we derived from the last problem, 0.2 plus 1 divided by KNRD. So that's equal to 0.2 plus 1 divided by 79.05. So I get that VDS at point E is equal to 0.2127 volts. So VDS at the bias point Q is equal to 0.2127 plus 0.2 volts. So VDS at point Q is equal to 0.4127 volts. That is just the first part. Luckily, the rest of the problem is pretty easy, so let's keep going. Okay, so part B asks, what is the gain achieved? So gain is AV, which is equal to negative Kn times Rd times V overdrive. We already know that Kn times Rd is equal to 79.05, and V overdrive is equal to 0.2. That's equal to negative 15.81 volt per volt. What is the signal amplitude, BGS, that results in the 0.2 signal amplitude at the output? Okay, so basically if I took my input signal amplitude, VGS, and I multiply that by the absolute value of my gain, then I'm going to get my output signal amplitude, VDS, which we know is 0.2 volts. So we can just say VGS is equal to VDS divided by AV. So that's 0.2 volts divided by 15.81 volt per volt. And that is equal to 12.7 millivolts. All right, let's keep going with part C. All right, let's take care of parts C and D on the slide. So part C, if the DC bias current in the drain is to be 100 microamps, then what value of RD is needed? So that drain current is ID, it's 100 microamps. And we can solve for RD, right? If we take a look at this wire here, we can say that ID is equal to VDD minus VDS. And this VDS here is at point Q, which we already calculated. And that would be divided by RD. So now we're just solving for RD equals VDD minus VDS at Q divided by ID. So that's equal to 2 volts minus 4127 volts, yeah, divided by 100 microamps, which is 100 times 10 to the negative 6 amps. And so I get that RD is equal to 15.87 kiloohms. Lastly, we have part D. If Km prime is equal to 400 microamps per volt squared, what W divided by L ratio is required? Okay, so we know that Kn times RD is equal to 79.05, and we know what RD is now. So Kn is equal to 79.05 divided by 15.87 kiloohms, which is equal to 4.98 milliamps per volt squared. And Kn prime is 400 microamps per volt squared, and Kn is just equal to Kn prime times W divided by L. So therefore this ratio is equal to 4.98 milliamp per volt squared divided by 400 microamp per volt squared. That is equal to 12.45. And that completes this problem. Thank you very much for watching. For any comments, questions, or video suggestions, feel free to reach me in the comment section or by email, and have a great day.